So good afternoon. I am Joshua Arvin Lat, and I am the Chief Technology Officer of Combinate, Insights, and Jepto. These are three Australian-owned companies. So my topic for today would be designing and building complex machine learning projects with Python serverless X containers. I'm also the AWS machine learning hero. But the concept, so even though I'm basically the machine learning hero of AWS. I will talk about the concepts in a way where you can use it in whatever platform you want to use. Because basically, once you learn the concepts, it's easy to apply it to a certain platform like Azure, GCP, AWS, and so on. But from my end, I'm here to share my knowledge and expertise and experience with machine learning. And also, I will also make sure that you guys are able to deal with more complex projects bit by bit over the next couple of months. And hope you learned something from this session. So to quickly introduce myself again, so I'm also the author of a future book. So it will be published probably 2021. So probably 6 to 8 months from now. It's called the SageMaker Cookbook. It's a machine learning book. So stay tuned. So no info much on that yet. But yeah, I'll keep you guys posted. And I'm also one of the subject matter experts in AWS certification. So I'm not from AWS. Just to let you know, I was just hired as a volunteer to help update stuff. So yeah, been updating the machine learning stuff on the AWS side of things. So enough about me. It's time we talk about concepts, so that at least we can use these concepts to learn more about the harder stuff. So for this session, the goal is basically to process a sample data set on the left side. So as you can see, it's a really simple CSV file with just 20 records. And the goal is to process that CSV and convert it into something on the right, where we have some sort of linear regression model trying to generalize the points and the numbers there. So if we so in case that we have a new data point, let's say we have the x-axis, which is, let's say, the experience is, let's say, 12.5 years or something. You have an idea on what the salary or what the expected salary would be of that specific individual. So basically, the goal here is to use this data set and use that data set to perform predictions for future records which are not part of this data set. So it's a really simplified example, but we'll use this one and then build on top of that to build more complex solutions. Okay. All right. So the machine learning process is actually not as simple as this. But for the sake of demonstration, the goal is for me to describe quickly what are the different parts used in machine learning. So basically, it's like it's not as simple as this. Trust me. It's like there's a cycle there. You start with this one, and then if this part fails, or if you need some additional configuration stuff or cleaning, you have to go back to step one. But for the sake of this topic or in session, let's start first with the simple explanation of the machine learning process. The first one is data collection. The goal there is to collect as much data as you can, and then do not expect the data to be clean. That's why the second part is necessary, where you need to prepare the data and clean it. There are also other steps involved in that specific part. But yeah, cleaning there is probably one of the more tedious tasks in the data science and machine learning process. Sometimes the columns are not need to be combined and so on. Sometimes some columns need to be deleted. Sometimes some records have missing values and so on. So you need to have an idea on data interpretation and also trying to analyze the data and seeing how it would work on the later parts of the process. The third part is data visualization and analysis. So that's where you use your EDA techniques. You need to have a good idea on which charts to use in specific cases. Let's say that you want to check if there's a relationship between one variable and another. Try to use a scatter plot to get things started. So it depends on the data that you're processing. So it's different for text, it's different for images. In our example for today, we'll just talk about really small numbers where we just use 2 columns from our CSV file. Feature engineering, that's where you engineer features, quote unquote. So that usually happens when you have a good understanding of the data and you want to, let's say, generate new columns based from existing ones. So this one, more or less, is an art. Really depends on your experience, and you are a good data scientist or machine learning engineer if you have a good feel of how the feature engineering process works. Model training and parameter tuning, or hyperparameter tuning. The goal here is for us to first perform the train test split, and then get 70 to 80% of the data for training. Use that training part to generalize and create a model. And you can also do hyperparameter tuning, where you have the opportunity to run the training task multiple times using different parameters and hyperparameters. And then the output of that would be a model. A model meaning something that you can use to perform predictions in our example. And then we have model evaluation, where you will use different metrics to evaluate the model. So this one is a very simplified process. There's a more complex process regarding this. There's a lot of ways to evaluate the model. But yeah, that's one of the things that we need to know to check if the model that we've created or we've generated is good enough for us to perform the deployment. And then finally, we deploy the model, meaning the model that we've created during training, we deployed that into an inference endpoint. So once you have that endpoint, let's say that you have your websites or your web applications or your mobile applications wanting to use that endpoint. The mobile app, for example, can easily just send a payload. The endpoint processes that payload and returns it back to the mobile app with, let's say, a prediction. Now that we have a good understanding and review of what the machine learning process is, it's time we take on the more complex stuff. So for those who have been using Python for a really long time, the thing that we need to know here is that if you type something in your terminal in the Python shell, you'll see the Zen of Python. Yeah, so I've extracted 2 lines from the Zen of Python, and you can see here that simple is better than complex, and complex is better than complicated. So what do I mean by that? The goal here is to understand that at some point, things will become complex. Things will never always be simple. That's the reality of things. And once we have accepted that things may get complex or things may get complicated, it's now time to reduce that complexity and make sure that we get to make things as simple as possible. So right now, simple is better than complex. If you have a complex system, if it's going to get you to work on it for 30 hours to handle that complexity, maybe there's a simpler way of doing the same thing. And maybe there's a simpler solution or simpler alternatives to turn that 30 hours of work into, let's say, 2 hours. And there's less maintenance to work on that specific item. Complex is better than complicated. It's much better to understand the internals of the system and tag it as complex rather than complicated where you have no idea what to do. Yeah, so from complicated, you can turn it into complex, and from complex, you can turn it into simple. And you will have several iterations in order to improve the current state of the system or your code or the process. Focusing on your goal. So right now, before I flash the next slide, let's not forget the fact that when we're doing something, we have an objective and we have a goal. Sometimes, as technical people, we have that tendency to try out all this cool stuff, all this machine learning tools, frameworks, and new techniques. Oh, I have read something in the blog post that this new discovery is cool, so I would like to try that out. The problem there is that when you are in the real world and you need to apply that sort of solution in your company, the first question is, what's the goal? What's the objective? How will that help the business? Is the business even aligned with what you're doing? That's the first question. Because sometimes when people take on a data scientist role or a machine learning engineer job, sometimes they love the job too much that they forget about thinking on how to help the customers. So there are two parts there, and the goal there is to map um, the first part and the second part. The first part meaning the business needs, the needs of your customers, and then second part is what can we offer. So the first part is that let's say that there's a customer that needs some sort of recommendation engine or recommendation system. You cannot just recommend a solution which does not map to that specific need or specific goal. That's why you need to have an arsenal of tools and options so that you can recommend certain, let's say, solutions or strategies to solve that specific problem. And right now, if you have no bandwidth to perform research or to do research, it's about time you take a step back and understand that no matter how cool your solution is, at the end of the day, it's going to be your customers' needs that need to be prioritized. That said, here's a quick example of how to map solutions to specific business problems or machine learning problems. Here on the left side of things, we these are some things that machine learning can solve. So the first one, let's say, is anomaly detection. Second would be product recommendation, forecasting. You can also do image and video analysis. We have document classification and so on. So let's stop here first on the left side and try not to read those on the right side first. So these are just some examples on how to solve the left side, but you can technically replace that with other solutions. For example, here, oh, I have no idea what SageMaker is, and I have no idea what random cut forest algorithm is. So I'll probably look for another solution. That's one option. Yeah. So that's one option. The other option here is to basically list down the second step ideally is to list down all the possible solutions on the right side and try them all out. Try to see which is the best solution for the certain problem given the context. Let's say that what you need is a real-time anomaly detection system. Maybe you can use, let's say, the Kinesis random cut forest function there, where you can automatically get the anomalies in real time. And that's a different solution from this one. So like what I told you guys, do not try to use this solution for a solution here at the bottom, especially if it does not fit. Sometimes you will end up asking data scientists and machine learning engineers and developers, hey, what's your favorite machine learning tool or algorithm or service? When in fact, the solution actually depends on the problem that you're trying to solve. So let's say document classification, then there's probably a certain set of solutions to solve that problem. And depending on the solution, the cost and the amount of time to solve those problems varies. Yeah. So the first step here is to know what are the different solutions available. Yeah. So here's a sample Python code on how we can use SageMaker to solve a problem. So probably 50 to 70% of the audience members, for those of you watching it right now, have no idea what SageMaker is, and that's completely fine. SageMaker is one of the machine learning services of AWS, and it's used to abstract a lot of things. So if you're using a different platform, you'll probably replace this with a different tool, but with a similar behavior. And in this case, the goal of SageMaker is to abstract the things which are common to most machine learning projects. So this is just one example. You can also use other tools on this one, but the goal here is to understand which parts can be automated and which parts need to be custom. So this is the first step. This is a combination of both serverless and containers in action. So SageMaker is a serverless service, meaning that you try to use as much managed service as possible to handle the engineering parts. So for example here, you can immediately set the size of the instance, meaning the computer that's running to process your training job. And you can also update the count. So if you were a data scientist and you were to do this, let's say 5 years ago to 10 years ago, and there's no option such as SageMaker, then you would have to learn some engineering stuff, some web development stuff and DevOps stuff to do this. And it would take you probably 2 weeks to 1 month to build that system that allows you to do things from end to end, from data cleaning, from processing your data a bit before training, and then doing your training jobs, and then deploying it. And actually deploying it into a web API is a different story, because you need to make sure that you handle different scenarios where, let's say, you have to do blue-green deployments, you have to do A/B test, you have to check if you can do a multi-model endpoint, you have to also monitor the metrics in the production environment, and so on. So instead of us trying to waste our time there, the goal here is to use an existing service that basically does 80% of the job, the common task, and then you can focus on the 20% custom stuff. So what's the custom stuff? The custom stuff here would be the algorithm that you're planning to use. So this one, for example, we're going to get the image of the container using the linear learner algorithm. And just by reading this one line of code, you can see that this is a string parameter. So if you want to use XGBoost, just replace this with XGBoost, and you can already get the XGBoost container. That's kind of cool, especially if you're planning to perform multiple experiments. Because if you were just to perform a single experiment, just linear regression, just a couple of parameters, then you might not need this. But if you are planning to really take on a serious production project, and this one is a parameter, and a lot of things have been abstracted for you, and there are already built-in containers for that, then you can compare the results of 4 or 5 different algorithms, and even perform automated hyperparameter tuning with those different algorithms. And then with probably 20 lines of code, you can easily process a data set and then get the best model from the best model family using the different algorithms available. So as you can see here, going back to the slide here, you can see that the container image, which is a string, is obtained by using this function. So no need to understand these lines of code, but basically the summary here is that you have the container. And then the next one here is to initialize the estimator with the following parameters. The role ARN here is just to make sure that things are properly managed on the security end of things. And then you always need that SageMaker session. But what you need here would be to set the training instance size and count. And then also you want to make sure that you have set the output location. Because when you're performing the training job, you of course need the input, you need the algorithm, and then you need the output location. So input, and then there's the processing stuff, the training stuff, and then the result will be a model, and then the model would be saved in the S3 output location. So what's S3? So S3 is just the storage service of AWS. So you just put a file there, and tada, it's just a file location, file system. You can also set the hyperparameters. In this case, we have linear learner. It's a linear regression. It can do linear regression stuff. And then one of the hyperparameters you can set is mini batch size. So given that we're dealing with a small data set, we just need to set the batch size to 4. And then the predictor type to be regressor. You can technically do a lot of things with linear learner, not just linear regression. But for the sake of simplicity, these are the hyperparameters. And then, similar to the other machine learning tools and frameworks, you have the fit function or fit method, where the parameter is the training input. So I removed the train input line there, but basically it's just the S3 location, basically the location of your training data. Yeah, so as you can see here, you have these 4 lines abstracting a lot of things that you need to worry about, because these are 4 of the primary steps when dealing with machine learning experiments. And when you have abstracted a lot of parts, it means that you can handle more complexity, because there are different layers of abstraction, and you can technically deep dive and create your own custom container here. in case that you have your own algorithm that's doing other things. So let's say that there's a pretty new algorithm out there, open source, and you want to try it out, and there's no built-in algorithm for it. Then you can just use your own container and use the container strategies to give yourself a bit more flexibility. So the reason why the title is Serverless X Containers is that you use the serverless stuff to make your life easy. And you use the containers and the containerization strategy and process to make your life, to make things more flexible on your end. So if you need the customization part, then you will use containers for it. So this is a good balance of containers and serverless in action. So a few more slides and then we'll proceed with the hands-on section. All right, so these are the parts which can be abstracted using SageMaker. The reason why I'm teaching you SageMaker is that we'll use that in the hands-on later. So you can feel, say, serverless and containers in action. And later, we'll also use a workflow orchestration service, which will allow you to see how we can organize things better on the production end of things. So right now, we're just talking about a really simple process. And the goal later is to have some sort of workflow. So step one, and then when this is done, there's a green light there. Then step two, the output of step one will be passed to step two, and so on. So it's going to be pretty cool because once you get that to work, you can easily build more complex workflows to deal with your projects. And those two things, so SageMaker, use it, and the orchestration workflow service, you can do a lot of things and easily just configure it to the needs of your project or your experiment. So what I mentioned earlier is that SageMaker abstracts a lot of stuff. And here, just think about this orange boxes. So this, I think these are orange boxes, not yellow. So these orange boxes, so try to count it. So 1, 2, and then 1, 2, 3, 4. So this means that we're trying to use 2 instances for this step. And then for this step, we'll use 4 instances. So SageMaker has a lot of features. No need for you guys to know about that. But what I'm trying to tell you guys here is that, let's say that I want to run a processing task that performs data preparation and cleaning. I can automate that work and automatically scale it to as much data as I need. Because in the example earlier, we just had, let's say, 20 records. But in real life, you'll probably be dealing with much larger data sets. And the speed of your experiment depends on the infrastructure that's helping you perform those steps. So in this case, if I just need 2, I'll just set the number 2 as the parameter without changing 99% of my code. So the advantage there is that the logic is separate from the infrastructure part, meaning you can focus on your experimentation and development work without worrying about the underlying details, because the infrastructure part is now predictable and it behaves the same way every single time. If you need 4 instances, set it to number 4. If you need model training to use 6 instances, then do it. If you need to use GPU, etc., then there's just a parameter for it. So that's the advantage of using a managed service to help you with your experiment. And I'm just giving you one of the solutions because there are technically many solutions out there, like using Lambda, using API Gateway, and so on. So now let's talk about using custom containers. So this is what I mentioned earlier, where I mentioned that there are a lot of built-in algorithms in SageMaker. So linear learner, you have XGBoost. So XGBoost is an open source algorithm, but what AWS did is it used XGBoost and created a container that's already optimized for the SageMaker infrastructure. So let's say k-nearest neighbors, for example, you already have your open source algorithm for it, but it's usually not optimized for distributed training. It's also not optimized for the infrastructure of AWS. So what AWS did is it tried to create the containers so that people can already use that algorithm right away. And then if the built-in containers don't work for you, then just bring your own container. There's just a really simple tutorial on how to do that, wherein you just need to follow this set of guidelines where you get the inputs and hyperparameters from this directory, and then you store your output in this directory in the container. And then when the container has finished running, then the SageMaker service knows where to look for before uploading it to the S3 bucket. So this is pretty cool because if you are a beginner, you might want to try out the built-in algorithms first, try things out. And then if you are pretty advanced or pretty intermediate, you can just bring your own container in different steps of the AWS in the machine learning process. Yeah, so here, before we start our hands-on labs, you can see that I can use a custom container in at least 3 of these different parts of the machine learning process. Because in some parts here, you may end up using a different language, you may end up using a different algorithm, you may end up using something that your environment is not capable of dealing with, and that allows you to focus on what you need to do here in a seamless fashion. And you can easily create one Jupyter notebook that's using different containers, different instances, and different environments. So guys, just a reminder, I'm not trying to sell this service to you. I'm just letting you know that there's a service that exists that can help you use both serverless and containers to solve your problem. Yeah. Thank you for listening to the first part of the talk, and I'm going to share this link so that you guys can um, fill out and put your name in that sheet. Do not put your email addresses, just your first name. So open that because we need to assign an environment to each of you. So I have created a new account, a new AWS account for each one of you. So you're a very lucky group. And you'll get this environment for free because I created for you. I'm the one paying for it. So here I'm just using North Virginia as the region. And you can see that I have created 3 Jupyter notebooks or environments in this region. So this one is A2 to A4. Okay. So the first step here is to put your names here in column I. And then the next thing that you'll do is click this console link here. The username is this column B. So for example, for Ming, you click on this link and then use B1 as the username and then PyCon 2020 as the password. Yeah, so there's actually room for 60. So I have prepared 60 environments, 50 to 60 environments in case that there's a lot of people joining. Yeah. And then you'll see, and then the next step there is to go to your region. So for Ming, for example, go to Ohio. So if you check the Ohio region, you would see probably around 2 to 4 notebook instances there. So instead of us wasting time waiting for these notebooks to start, I've already started them. I already created them for you. So for example, for Ming, the assigned account is B1. All Ming needs to do is click Open Jupyter. So when Jupyter is clicked, you'll be able to access your environment. So once you have performed those steps, click just type in done in the chat section, and you will see something like this. So B1, that notebook.us is to that SageMaker.aws. So again, don't use someone else's environment. So put your name here, and then look for the assigned region and username and log in. Okay, so I won't be using Ming's environment. I'll be using mine. I'll be using my environment. So these are new environments. So again, password is PyCon 2020. And this is the URL. Okay, so what will happen if I open my Jupyter Notebook? So most of us probably haven't used SageMaker yet. So I'll give you a quick introduction. So a Jupyter Notebook is simply an instance or a computer that hosts a Jupyter application. So when you open it, you can see that I just opened Jupyter. Yeah, it's simple as that. It basically made it easy for you to perform experiments and so on. The next step is to look at the instructions, instructions tab. So once you open Jupyter, you open a new terminal. So there's a new terminal here. If you guys can see this, there's new. And then there's a terminal option here at the bottom. Okay? Need to sign in IAM user account? Yes. You need to use this link. So for Ming, for example, the username of Ming is, so I'm not sure if it's the same Ming, but if this is that one, then you'll use B1 as the username, and then PyCon 2020 as the password. So that once you have opened the terminal, all you need to do is open the instructions tab, and then copy, then type this one, CD SageMaker. So CD SageMaker. Actually, you can see the contents of that directory, and then you type this one. So what does this command do? So AWS S3 copy this file to your notebook, to your instance, to the current directory. So for those who haven't used the AWS CLI command before, no need for you guys to worry about it because we'll only use it once. But it basically automates the copy process from the S3 bucket. So a bucket is just a directory. So this is the directory and this is the zip file. So what we did is we basically copied the file from S3. So if I open S3 right now, and you can see that we have a lot of buckets. Yeah, so I'll explain later why we need so many buckets here. So I think this is the bucket that we were looking at, and this is the file that we were trying to download to that notebook instance. So what we did is we copied. So this is the first step. We went to the SageMaker directory first, and then we used the AWS S3 command to copy this file to the current directory. So once you have downloaded that, if you try to list the files in your directory, then you can see here that the zip file is there already. So once that you have the zip file already, you can just unzip it and then run that. So I'm not running it because I already have the files in that. Actually, I can because I think it's going to create a new folder. And so once you unzip that, you will see the PyCon 2020 folder. And then when you go back here and then click refresh, you will see a PyCon 2020 folder here. And that's where you can see the lab and the input file required. And then the next step there is to open the first lab. Actually, you can also open the second lab, but not yet. For those who are already in the subsequent steps, you can actually try running these lines of code. Just a fair warning that you need to update the unique name to your assigned label, and you need to update the following lines of code because you need to update the S3 bucket here, and the instance size later. Yeah, so feel free to run this ones first, but replace the S3 bucket with the S3 bucket here in this column.
But I couldn't unzip the Python 2020.
Okay. In order to unzip Python 2020, can you share your screen? Or are you allowed to share your screen? So that other people
Oh,
can.
okay. Let me share my screen.
Yeah. So for those who are already ahead, feel free to follow the next steps in the instructions tab, and you can actually start running the job.
All right, let me know if you can see my screen, please.
I see. You forgot the dot. So if you copy the so if you go back to the if you go back to the spreadsheet, there's actually a dot after the zip file. So there's a space and a dot. So
Oh, okay.
okay, yeah.
Let me copy.
Yes, yes. For temp training.csv for Sir Andrew, the reason that it's missing is that you need to run the other steps first. So this one is for Andrew. There's something called you need to run this part first. Yeah, the exciting stuff actually starts now. So here in the lab, technically all you need to do is press enter, but do not forget to replace this with your name. Why? Because if you don't replace this with your assigned label, then you may end up overwriting the files of other people. So the assigned account or the name, just use it as a unique name, and whenever you get to see something like this, you need to replace it with your specified region. Okay. So for example, so let's say that I'm Francis, and then I will have to look for my region, so Tokyo, and I will need to get the S3 um, bucket name. So this one is kind of confusing. So I'll just put something like this. So I'm going to copy this one, and then I'm going to replace this one with something like that. The reason why we need to do it is that the SageMaker notebook that you're using, which has been created in that specific region, requires your training file to be in the same region also. Because the original PyCon 2020 workshop directory, I think it's in North Virginia. Yeah. So you need to replace this one, and you need to replace this one also. You need to replace those two. So if you find similar lines like that and there's an error, you're probably using, you need to replace the S3 bucket. Okay, so I need to put it back to the original um, version. So once you have replaced that, it's time to start pressing enter. Yeah. Okay, so this is a quick demo. So I'm going to press enter there. If you see the asterisk on the left side, it's still processing. Okay, so what happened here is I assigned this value to this variable. I'm going to import pandas, loading. So we're using a T2 medium or T3 medium, that's why it's probably slow. And then I'm going to read the CSV file. And I want to check what the CSV file contains. So we have this CSV file. You can see here that there are just two columns that we need to be aware of. Students in class and average score. You can see here that the average score might depend on the number of students in that specific class. And what do I mean by that? Because there's probably a relationship between these two numbers that whenever there are too many students in a class, maybe the average score of that group decreases. Because of course, when there's just one teacher and then there's 50 students, of course the number of maybe it's not as effective as one teacher assigned to 20 students, for example. So this is just a sample data set. And then the next step here is to import matplotlib. And then you just need to press enter on this one. And then you can see that I have created a scatter plot trying to compare the number of students in a class and the average score over 100, which is over 100. What I can see here is that, let's say this, so how do I interpret this scatter plot? Let's say that for batch A, which is just an arbitrary label, if there are 44 students in a class, the average score would be 55. So let's look for that record in this one. So if the number of students is 44, what's the average score? The average score would be 55, somewhere here. So it's probably this one or this one. Yeah, that's probably the dot that's representing this specific record. So do that 20 times and you'll have 20 points, something like this. So when you try to read this, try to check this visualization, you can see that there's a pattern. That when the number of students in a class increases, the average score decreases. So there's some sort of linear relationship here. So maybe we can use a linear regression algorithm. Yeah, so this is pretty much simplified, just to show the process. In the real world, this is probably not as simple as this one, but for the sake of simplicity, let's just use this example. So step one would be to do a train test split. So technically, there's train validation and test, but for this example, we'll just do train and test. Okay. So in the train test split, you just use this function train test split, and what it will do is it will assign 70% of the data to the training data set, and then 30% of the data to the test set. Okay, so when I look at xtrain and xtest, you can see that there's probably 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then you'll see 6 test records. So what's X and what's Y? So you can see here that's X train and then there's Y train. So X train and Y train, if you look at this one, you can see that this is the number of students. So X is the number of students and Y is the average score. So if you look at the original table, you can see that this is X and this is Y because we're using X to predict Y. All right. The next thing that I think I remember, I need to press enter. Yeah. So I press enter there. And then I press enter here. So the reason why I put this ones is that this allows us to see what their value is before using it in the next step. Then when you press enter, you can see that I have created a training data frame that has something like this. Take note that when you're using linear learner, the Y values need to be in the first column. So earlier, it looks like this. What we did is we extracted a couple of records here, and we needed to make sure that the first column contains the target variable. And then I'm going to create a temporary directory, and then I'm going to save the training data. I need to make sure that there's no header and the indexes are removed as well. And then when I run this command, I can see that the training CSV file is there. The next thing I need to do is upload the training file to Amazon S3. So I need to enter this one. So let's wait for 5 seconds. And then you can see here that I have uploaded temp training.csv to S3 PyCon 2020 workshop A1 input training CSV. In order for me to check if it has really been uploaded, I just need to go to the S3 service and then look for PyCon 2020 workshop. Then there's a folder here, A1. And then there's input. So input. And then there's, hey, where's my training CSV? AI input training CSV. Oh, there you go. Yeah, there's a 5-second lag. So this is the file that I've uploaded from this notebook. So it's now time to start running this. So I enter this one. This is basically the prerequisites, the initialization stuff. I have the role ARN and I have the session. And then, again, make sure to update this later with the value here in the S3 bucket section. I think I can close this one. And then I'm going to press enter on this one. If I want to debug what the values are, then simply just print it here. Because sometimes you may end up forgetting that if you press enter or not. Yeah. So the output directory would be this one. So what will happen here is that the output directory here would be just beside input directory. And then I'm going to initialize the container and this one. So if I add another line here and type container, you can see that this is just a string pointing to the linear learner built-in algorithm. So in my presentation earlier, you can see that I can replace this with XGBoost or any other algorithm, as long as the input data is accepted by that algorithm. Or I can even use my own custom container to make this work. The next thing I need to do is initialize the estimator. Okay, so let's try using a larger instance type. So let's try 2x large. So in case that you're encountering a problem, and then you're encountering a problem where the maximum number of instances for this instance class has been used up, just update this instance type. So I'm initializing it like this. If I want to debug what the estimator properties are, there's something in Python called __dict_. So the buttons I'm pressing in the keyboard is Shift Enter, so that you don't need to click run every single time. Yeah, I should have told you that earlier. Yeah. So and then you can see here that the image name is this one. This is the hyperparameter dictionary, and so on. So this is one of the ways to debug what has been set in the estimator object. And then I set the hyperparameters to regressor and mini batch size equals 4. So if I were to debug that, it's the same technique. You can see here that the hyperparameters has been set to predictor and mini batch size 4. And then I'm going to wrap it with train input. I'm basically telling SageMaker that the content type is text CSV. And then I'm going to run the training job. All right, so once you click enter on this one, and then there's an asterisk, all you need to do is wait for 3 to 5 minutes. So in case that you encounter an error here, all you need to check, if you see a region-related error, then change the region. If you see an instance-related error, just change the instance type. Okay, so the available instance types are ML, M4. So just look for the available instance types. So for training, loading. Yeah, so you can use these instance types here. So if somebody else got to run their training task first, just use 2x large or 4x large. Yeah. And then for the deploy operation, once that is done, just continue clicking on enter. So you need to wait for 5 to 10 minutes for this one to complete. And then this one will probably take another 5 to 10 minutes. Yeah. Any questions? Yeah.
Yes, Ars. Hello? Hello?
Hello? Hi.
Yes. I want to ask for the estimator, because you designed the estimator, why do you want to separate the parameter from the estimator that create?
Sorry, can you repeat your question about the
I,
estimator?
I don't know why the set hyper, is it a good practice or common practice to put the set hyperparameter from in another cell, in the cell 71, I think. Yeah.
This one. This one.
Yes. Yeah.
Yeah, yeah. I actually, this one is a simplified example. So we're not talking about the best practices first. Yeah. Actually, this one is not even the complete workflow for this one. Because when you're doing automated hyperparameter tuning, this one won't look like this. Yeah, but yeah, good question. Yeah, but yeah, we can answer that separately after the call. Yeah. Thank you.
Okay, sure.
Oh, it's pretty smooth. Okay. All right. So probably all of you are stuck in the training step. So once the training step is done, you'll probably see something like this. And then all you need to do is run the deploy. I'll do 2x large or M5 2x large. I'm still sharing my screen, right? Yeah. And then I click enter. So you can see here, oh, uh, the account level service limit, yeah. So I'll use a different one. Oh, another limit. Yeah, yeah. I'll use a different one. M for, what is it? X large. Really? Uh, hmm. But didn't I replace it? Um, yeah, we reached the limit. Um, let's just select one and then replace this one with. Anyway, if you can't get this to work, that's completely fine because this is one of the more important parts, and I'll share the different techniques later. So let's fix this later. I'll be going back to my presentation. Yeah. All right. So deployment solutions. For deployment solutions, we're actually on the deploy step. These are some common deployment solutions. Let me check first if you guys can see it. So can you see my screen? This one.
Yes, we can see your screen.
Thank you. So for common deploy solutions, you can see that you can do it without SageMaker. You can do the training in SageMaker, get the model in the S3 bucket or S3 folder, and then deploy that in an EC2 instance, create a simple Flask website, and then load Apache MXNet, and then basically load the model from the file, and then use that for prediction. So you can do that with this type of deployment solution. In this one, you can also use containers. So a quick upgrade of this solution would be to use Docker, and then in your Docker container, you have your web API, your inference endpoint, doing the same thing as this one, but in this case, this is a container. Okay, and then you can have your load balancer, you can have Kubernetes there, and etc. You can also use the built-in algorithm plus SageMaker endpoint to basically continue what you ran earlier. So earlier you ran the training job, right? Once you have that model will be used as a parameter to create the endpoint. So the step earlier where we encountered some instance error because we used up all the instances available. it's basically this step. And the cool thing here is that it's just a single line. So if we go back to this lab notebook, you can see that this line actually does a lot of magic for you. So when I was trying it out years ago, it seemed pretty straightforward that it looked so harmless. But in reality, there you can actually perform a lot of different deployment solutions there. For example, you can use a custom container that hasn't even been trained using this service. So let's say that I already have a model in the internet. I can just create a custom container and host it in the SageMaker endpoint. So even without the training steps there, I just extracted some sort of neural net model. I can just deploy it in the endpoint right away using the container strategy. These are some more intermediate or advanced alternative deployment solutions. And I think these ones would help your company save some cost also. So once you have that model, you can technically deploy that model inside a Lambda function. So if you want to know how this works and what Lambda is the serverless function as a service of AWS, where you just run, you can just type in the code there, and Lambda just runs that code. So what you just need to do is store this inside the Lambda function, and then the Lambda function simply just uses that model to perform predictions. It's also possible to do something like this, Lambda triggering a SageMaker endpoint. What happens here is that you have an API gateway. So that's your layer, that's your API that triggers your Lambda function, and the Lambda function will trigger the SageMaker endpoint. And then a newer shortcut would be to remove Lambda altogether and just have API gateway trigger the SageMaker endpoint directly. So what's the SageMaker endpoint? That's the endpoint created by the deploy function, the deploy method in the lab earlier. So a mapping template is basically just using the templating languages used in API gateway, where instead of creating a separate Lambda function for it, you can technically trigger SageMaker right away, which is pretty cool. And then finally, you can actually deploy your model inside Fargate. So in Fargate, you can run containers there. So similar to this step where you're using a container to host your to run your inference stuff, you can do the same here in Fargate. Yeah, and you can also do that in other platforms, because once you have that model, deploy it wherever you want to deploy it. So these are just a few examples using the AWS stack. Okay, so just replace this with some other counterpart in your other platforms. Okay, so this is the fun part, managing machine learning workflows. So this is the most important part, because the title of this talk is Designing and Building Complex Machine Learning Workflows. I actually can't remember the title. The title is Designing and Building Complex Machine Learning Projects with Python, Serverless X Containers. The important word here is complex. And I think it's not as simple as that. There will be times where you will have to perform model retraining. Let's say that you have new data and you have to perform retraining of your models. Do you always want to run it inside a notebook? Maybe there's some way for us to automate the entire process, right? So let's say something like this where you have if-else conditions. You can use an orchestration service to automate the work for you, so that all you need to do is trigger this step and all the other steps would run. So this is an example. I just took some screenshots from lab number 2. But what you can see there is later when we run lab number 2, you can see that I can do whatever we did in lab 1, but this time we're going to create a workflow for it with just a couple of lines of code. So we're going to make use of SageMaker and step functions. So step functions is a service that helps you orchestrate your processes and workflows and jobs. Yeah, so this one is a separate topic of its own, but for the sake of simplicity, we'll use the SageMaker data science SDK to basically connect SageMaker and step functions, where what happens here is that instead of us trying to create this manually in step functions, a couple of lines of code would allow you to automatically create something like this. What this does is that after the start part starts, you can see here that it starts the training step first. So the training step is basically the 3 minutes you waited for. And then after the 3 minutes, this one will turn green. And the model step would basically just do some additional stuff there, create an endpoint configuration, and then finally deploy the model in the inference endpoint. So this one would be white at the start, and then after a few minutes, this one will be green, 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 and you can actually debug which step had an error. So in case that we encounter an error, that's completely fine. At least we can use this one to see, oh, okay, we reached the number of the max number of instances we can create using M4 large or something, and we cannot proceed with this step. But when we debug this one in step functions, we can see that, okay, we got stuck here. And this is good because when you're trying to maintain and manage a lot of complex workflows, having something that allows you to visualize the entire process will help your team adjust right away. Because in a company, there are different layers. There's the management team, there's the development team, and so on. And if we want to know what's already happening with a certain process, instead of us trying to waste the engineer's time, maybe a manager can just check the step functions UI and then just see, oh, there's an error in the deploy step. And then if you want to deep dive, there are also other steps here. So yeah, so that's pretty cool. And then let's proceed to the lab number 2. So there's a comment here, the drawback of using API gateway to SageMaker immediately is that you cannot clean or reprocess the request received. That's true, that's correct, because the mapping template is limited. But if you need more intermediate adjustments, actually you can reprocess it a bit, but there's a certain limit because it's just a templating language. If you need a more intermediate processing between Lambda, between SageMaker endpoint and API gateway, and that's the time you introduce an AWS Lambda function between those two. So good point, Albert. Okay, so we have a few minutes left. The next step is to open lab number 2. Okay, so for all of you, we need to make sure that we get to delete the endpoints here. Oh, there's a winner here. When was this created? Today. Okay, so one of you was able to create this one in this region. So before we start, feel free to delete this one if you're done with the prediction. I'll process this one with you first and explain what's happening in this other part before proceeding to lab 2. What happens here is that I'm going to use this endpoint, the endpoint I've created. So this one, we just encountered an error because we ran out of like possible instances to use. That's completely fine because we need to do lab 2 anyway. But this one, we just needed to update the predictor parameters, basically the values here, to help us use a CSV format to perform predictions. So this one, I'm going to accept 35. So what's 35? 35 is the number of students in the class. So let's use 34 as an example. And the average score should be somewhat close to 66, right? So here, it's close to 66, which is 65, yeah. So the regression line that we've created, the model that we've created, the linear regression model that we've created, accepted 35 and then gave out a 65, meaning that it's trying to predict that if you get a number of students equal to 35, the average score would probably be 65 for that class. So you can create a handy function like this. And then if you visualize the results, I just created a data frame so that it's easier to visualize things. But when we visualize it, you can see that we can create a line here. And this is your linear regression model line. So yeah, it represented this scatter plot well. Okay, so what we have in lab number 2, you can actually start pressing enter. But if you encounter an error on the later stages, just delete the endpoints. So replace this with A1. Half of this lab is basically the same. Actually, I'll just explain it, and you guys can run it. Half of this lab is actually from lab 1, and that's intentional. The difference here is that instead of me running the training job right away, after I have uploaded it to S3, I have started creating step functions, the step functions workflow. So step 1 is to install step functions or to make sure that we're using the right version. I'm going to assign the workflow execution role. So I have created this for you so that you won't have to mess with some IAM stuff, some security stuff. This one is already working for you. And then what I'm doing here is I'm trying to define what the workflow looks like. So we have the execution input, the training step, the model step, endpoint configuration step, and endpoint step, and then finally the chain. And what I'm just doing with the chain function is to chain all of them. So all of the steps I've created here, I'm just going to connect them and create the workflow definition. What this does is it just generates a random string so that if we run the training job multiple times or the deployment endpoint multiple times, we won't encounter a conflict. So let's say that I have something like this. Oh, I didn't import UUID. And then this one, I will get a random string every time I run this. Every time I run this one. So what will happen here is that I'm going to generate a random string to name the workflow. So the name would be workflow plus random string, and then this parameter, the step functions workflow definition. This is this one, the one I just explained earlier. And then you can visualize your graph. Actually, it might be a good idea for me to just press enter. Training data. Yeah, I'll go back here at the start. Okay, enter, 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 enter. So I create a training step, endpoint configuration step. Okay, good. And then I create the workflow, and I want to visualize my workflow. You can see that my workflow looks something like this. So there's start, there's training step, model step, create endpoint configuration, and deploy endpoint. So okay, that's a lot of magic, right? So where did we create endpoint configuration? It's somewhere here. So we created this one here, create endpoint configuration. This one. And if you want to know where we initialize model step, we just created it there, and basically it's stored here. And then when I run this workflow.create, you can see that there's an Amazon resource number here. If I go to step functions, we're still good. You can see that, oh, there are some people who have actually executed that. You can see that this is the workflow this is probably the workflow that we've created. I can't remember the name. 7C something and then 0421. So 0421, I think this is mine. And then if you look at the workflow, if you look at the definition here, you can see that instead of writing something like this, we use Python code to generate this workflow. So you have your training step, model step, create endpoint configuration, and deploy endpoint. And then when we run it, we will execute it. Yeah, so regardless if it succeeds or it fails, we will see that it's running here. Yeah, so you can see that it's running here. If you debug this one, you can see that it's going to update this part every time a step is completed. You can actually do the same thing here in render progress. You can see here that it's running the training step. Probably will encounter an error here in the deployed endpoint part because we probably ran out of instances to use. But at least you'll see that it had an error here, not here or here. You can also list the execution events. So this is the one I've shared in the slide. And then I can also list the number of workflows created in this region. And then I can just check on the progress. So yeah, so it's a major upgrade over lab number 1. And for all of us right here, feel free to first delete the endpoints. So again, delete the endpoints in SageMaker in case we ran out of like instances to create. But yeah, this one is pretty powerful because this is just a simple example, but you can create really complex workflows with this one using the step functions API. So this one is just obviously sequential flow, but you can technically do a retry here. If you can do an if else here during retraining, what you can do is that you can check if a certain value is below or greater than a certain value. Let's say that you want your precision value and recall, precision value and accuracy over a certain value. And then if it's less than that value, then it will not deploy that model. You can do something like that. So yeah, that's actually it for this session. We'll spend the next 5 minutes waiting for you guys to run your lab number 2. And what we can do is we can just check what's happening now in step functions screen. Okay, so who here has any issues, or can you type here all good if you're able to get the step functions workflow to be created and then you're able to execute it? Good. So if you have questions, guys, you can email me. And yeah, I'll wrap this session up. So we have 4 minutes left. So yeah, I'll give you a quick summary of what happened. So again, simple is better than complex. Complex is better than complicated. When you're trying to start it out, start with a simple problem. Because if you cannot even create a simple workflow, then it would be much harder for you to deal with complex workflows. The concepts that I've shared is not just for the it's not just applied to the examples that we've shared, but basically it can be used to create and solve harder problems. Yeah, so you can just check the AWS blog for it. You can actually combine different services in AWS Step Functions. But the goal here is to understand that when you encounter a complex problem, the next step there is to divide that into smaller parts. So let's say that you have one big problem, you have 100 parts of your system. Try to divide that into 5 parts first. And then if you can find a way to group them together, then that would be great. And then finally here, do not forget that it's possible to bring your own container, both in training, in processing your data, and even in deploying your endpoint. So over the next couple of months or years, you'll probably see more options using both serverless and containers. And I'll repeat that it's not one versus the other. You can actually do both. and you can actually host your algorithm and your own container in the same endpoint. So when you create your SageMaker endpoint, there's something called multi-model endpoints, and you can do something like that as well. Yes, and then finally, you can use this and build on top of this, but there are actually a lot of different alternative deployment solutions in addition to this one. So these are just a few common ones. You can actually have your TensorFlow custom container or PyTorch custom container. There's actually a container for it in AWS. But let's say you have a new model and you want to deploy it right away, you can do it in different ways. And then finally here, this is just one of the options to create a workflow. There's also ML flow and so on. So there are different services. So I just showed you one, and that is step functions. But that technically, you can use other workflow orchestration services and tools to do your stuff. And then finally, when you're dealing with more complex requirements, in addition to simplifying it, try to find a way to make it easily visualized by other members of your team so that you won't need to deep dive and debug what happened. You can technically just see, oh, there's a red here, we encountered an error. And at least you'll just be able to debug this step only. And that's it. Thank you very much, guys, for listening to my session. And yeah, stay tuned for more. But yeah, that's it. Thank you.